So our first speaker here in the second section this morning is Peter White. Peter White is an irrigation technician at the Department of Plant Agriculture at the University of Guelph at the Simcoe Research Station. He works with growers that have subsurface drip irrigation installed to develop optimal irrigation and fertigation timing and recommendations for growing corn in Southwestern Ontario. Peter's a 74 grad of Crop Science Department at the University of Guelph. Peter and I have actually known each other for a number of years, specifically related to the drip irrigation project, which was funded under one of our programs called RAMI way back in 2015. And I was in fact there and have video of the day the drip irrigation tape was put in the ground. And so we look forward to hearing Peter talk about drip irrigation and giving us an update on how that's going. So, Peter.
Thank you very much, Bruce. Yes, Bruce and I have had lots of fun together over the years. Subsurface drip irrigation for corn. I know there's a lot of you people that are thinking in a year like this, well, what would we need that for? Well, I'll maybe show you why. Now, admitted, this is 2012. This is a picture of Judge Farm's field just south of La Salette. They bought the farm. There's about 80 acres there. They bought the farm for the chicken barn that's on it. They're broiler producers as well as they also have a hog operation. They want to grow quality feed for their animals. And as you can see in 2012, I drove by this field every day, and this is the best it looked. And needless to say, they didn't get any feed off this field this year. So they decided they needed to reduce risk and get more reliable returns. Judge farms between 3,000 and 3,500 acres, depending on the year. And they have crop insurance under one entity. And they have some really good land, and crop insurance didn't pay a dime off on this because their other good land made up for this. So we have to evaluate. They decided they have to come up with their own crop insurance plan. This is what the sample looked like when they started to take a little bit and decided not to take any more. So they decided they were going to have to irrigate. And they already were doing some irrigation on some of their land with a hard hose traveler, like systems that were already there in place for tobacco and for potatoes. And so they were quite familiar with the hard hose traveler, but one of Todd Bugner's friends, who's their farm operations manager, was playing around a little bit with subsurface drip, had done some research in it in Kansas and Oklahoma, and he put the bug in Todd's ear. So they kind of looked at what they were going to have to do on this. They have really good water on this farm. There's a big, good-sized pond, but they didn't have enough irrigation equipment to go around. So they were looking at a hard hose traveler, which is obviously the most prevalent system in our area. And so they looked at the cost, and for a completely new system with a hard hose traveler or to put in SDI, they thought the costs were about the same. Now, everybody told them that they were going to have lower energy costs and lower labor costs with subsurface drip. They're going to have the ability to irrigate anytime they wanted to irrigate, better water use efficiency, and ability to fertilize during the growing season. So that and these results. Now, Dave Blake farms south of Simcoe, and in 2012, he was very timely. He had just put some subsurface drip in. And on a very brief area, these are the results he got. He had 35 bushels, which is really non-harvestable. His overhead went 163, and the SDI went 258 bushels the acre. So that convinced Judge Farms that maybe SDI was going to be the way to go. So, now, I know I'm here to talk about results, but I just thought, and I'm even more so thinking that now, that with the group I've got here, maybe I better talk a little bit about SDI and what's involved with it. This is the tape. This is a 13 mil thickness tape. It's a little bit heavier than maybe a lot of tapes you've seen. There's actually a piece up here that you can take a look at after if you want to look at it. This is Netafim tape that we're using. We've used it on all our projects. It's not the only one on the market, but it's probably the most popular. This has an emitter that emits 0.18 gallons per hour, and those are placed every 2 feet along the tape. And there's you get an idea what the emitter's like. Right there, you can see a little flap. That little flap actually comes up and goes back down as the water is emitted out. It's one of Netafim's patented techniques that they use that says keeps the drip tape in the ground clean and working properly. So what you have to do is you have to put it in the ground. Now this is one of Annabush Irrigation's injectors, an Andros injector. There are several different types that are out on the market, but this is how we put the tape in the ground. It's a tape installation. We're putting it in this case, at about 14 inches. I think Judge Farms did most of theirs at 14 to 16 inches deep. We're putting it at 44 inches apart. This is at Judge Farms. You want GPS on your tractor because you don't want your rows all over the place. You want to be exactly 44 inches. We're putting the drip tape 44 inches apart. Some people go closer, some people go wider, but generally speaking, across the corn belt where they do broadcast soybeans and corn, 44 to 40 inches is kind of a standard. There's what the coils of the tape look like going through the machine. There's rollers on the machine to make sure that the tape is not damaged as it goes down and goes through the boot into the ground. After the tape is in the ground, you can see the tape is right down in there, already at 14 inches. We cut in trenches. You can see the trench here. Cut it in trenches, the header lines and flush lines. There's header lines put in at one end of the field, flush lines put in at the other. Usually flush lines are a little bit smaller because they don't have to deal with as much water. But this is a header line. And the most laborious part of putting this in is making these connections, because you got one to do every 44 inches. This is a piece of rigid 5/8 hose, and you go up and you work your way around where the drip line is, and then you put a little wire, a pull wire clamp on it and clamp it. We usually double clamp them in here. And you want to do this section of your work all in one day. Never uncover more than you have to do in one day, because at the research station we did, and it rained, and then we shoveled it out again, and then we shoveled the trenches out again and shoveled them out again. But once we got to Kansas, the boys in Kansas said, you only dig a trench that you can fill in today. That's it. But anyway, once you've got this done and get water into the system, it's a lot simpler. These are what the end of the flush lines that come out of the ground. You initially, especially when you put your flush lines in, the idea is to get water through the whole system, get water coming out the end, and once you got clean water coming out your end, you're good to go. You're always going to have some dirt that gets in the lines when you're putting a system like this. Once you've got clean water on, then you start testing your system, looking at your flow rates in the system, and then determine what kind of a job you've done. Okay, all these systems go back and they run into, this is Judge Farms pumping, filtration, and injector system. These are, these are sand filters, which are mandatory for a pond system. Now, the majority of the guys that I'm going to be talking about here today use ponds that were on their farm to begin with, but you need really good filtration for this system. So they use sand filters like this. This is a 30 horsepower pump for 80 acres. And there's a fertilizer injector over here. And of course, we have a water flow meter, which is absolutely mandatory for the system, because when you can't see where your water is going, you have to have a flow meter so you know whether or not your system's working or not, right? You don't have too many other ways to figure it out until the end of the season, whether you've got corn or not. But really, that's a key ingredient to the system. So this is what their pump house looks like. That's where the corn is. This is courtesy of the 360 Yield Center, but that's what it looks like when you knife down into the ground. Here you can see some spots that we dug up at Judge Farms in the spring of 2013, and the system is all there and working. Works good. I'll explain it later on in the moisture sensor section, but we actually have to dig down and find some of these so I can put the moisture sensors in at the right spot, but I'll talk about that later on this afternoon. So, what did all this do? We actually put in 2.5 acres of this stuff at Simcoe as well, just so that we could work with the farmers and so that we could maybe do some little different things than maybe they were doing or could afford to do. But so anyway, once it was all said and done in the fall of 2013, Judge Farms yielded 260 bushel per acre on their SDI and 165 bushel per acre right beside it in the field that was treated very similar beside them. And our plots at the station, our SDI plots went 248 bushel the acre, which was about a 15% increase over non-irrigated. So we still had some pretty good non-irrigated corn, but we're on a little bit heavier ground than the majority of these farmers are. Okay, for Judge Farms, and I'm really talking with Todd in mind here, because he's the manager, and this is the way he feels about what happened. He said, well, we got increased marketable bushels. They got much better improved grain quality for the livestock operation. In fact, our bushel weights are always well over 56 pounds per bushel. We've had excellent bushel weights with SDI. It's a long-term simplified irrigation system run by one person in season, and you have the ability to water the whole farm in one day. It's simplified the recording of measured irrigation for compliance with the water taking permit, because all you have to do is go look at that flow gauge, and it tells you exactly what you've used that day. And you know what I don't know whether any of you know what it's like, but when you're dealing with a pump and a traveling irrigator and stuff, and trying to pay attention to how much water you put on might be a bit of an issue. It's really simplified. I mentioned the problem with the crop insurance that they have, so they've optimized their production on this challenging land, and because they're getting better yields, they're improving the soil health and structure because they've got better organic matter. Now, we're going to say our changing weather. Everybody's talking about changing weather, and goodness knows there's some people that have had it way worse than we've had it over the last year or so. But just to give you an idea what we've been dealing with, as you can see, our long-term average is 7.1 inches for July and August. And 2012, we were down at 4.7. Probably the worst part of it, I'm not even showing here, because June in 2012 was really dry too. So we were already in trouble. In 2013, our moisture levels came back up a bit. We had an okay season. 2014, we got lots of rainfall. We're well above average. 2015, we're still a little bit low, but Todd is on very dry tobacco sands, and this is where we have these moisture levels from. Then came along 2016, and we knew it was worse than 2012. So this makes Todd look like a genius that they put this system in, because he's only had 1 year where he's had more water than the average ever since he put the system in. So you can see he put in and only had 2.8 inches in July and August in 2016. And we didn't think it could get worse, and this summer it did. July and August this year, as you can see, he only got 2.7 inches up there. And it was just dry as a bone. It's dry as a bone in between the rows there right now. Now, Jeff, I should mention, we were asked to take part in a program that NetFM calls their Corn Grower Success Days. And they invited Todd and Jeff and myself to work with them on a system where we would look at tissue samples, evapotranspiration, corn growth stage, moisture sensor readings, and tissue fertility in the corn crop as it's growing. So I work with Judge Farms and with Jeff Lipsick since I guess we started the middle of June. We were having weekly meetings every Wednesday morning, and the NetFM corn expert Tim Wolf would make recommendations to the guys on fertility additions as well as, how much moisture do you think we need to put on? So that's why Jeff is in here too. Now, Jeff, that may look good for Jeff, but Jeff had just put on some nitrogen and some micronutrients, and he got a freak storm. I think it was on July the 17th, the next morning, which hardly anybody in the area got, and he got, of that 3.9 inches, he got over 3 inches of it that morning. He would have rather had nothing that day, but it carried him for a little while. But anyway, anyway, I say our weather is changing, and it's so variable. We're just okay. Overall, our judge SDI yields over the years. Here's a kind of a brief description. In 2012, as you can see, as you know, they had their total crop failure due to drought. They harvested no bushels off the crop. 2013 was the first year they went 260 bushels and 165, as I said. 2014, they had just purchased a new planter, and they were having some residue and some placement issues with the planter. They were not happy with the stand in the field, but they still went 253 bushels with it that year, and the neighbors were 150. 2015, on our sandy soils, they're prone to frost in the springtime, and he had an early spring frost that knocked off over half of the field for sure. But he still went 140 bushels, or 240 bushels, and 150 bushels non-irrigated. Now in 2016, with a drought and western bean cutworm, they dropped down to 170 bushels, but the non-irrigated was 50 bushels, and 50 bushels is really not. We had Greg Stewart come by on August the 22nd, and he went out and with Mo Agostino, and they did this evaluation in the field, and I mean, the birds were already into the non-irrigated. It was just unharvestable, and so Greg estimated 50, he said at the best, but you can see a bit of the western bean cutworm damage too, but they went 170. Now, I should say Todd's philosophy on this too. People, you go back to it, Todd has people come in and he shows them around, and they say, well, geez, I don't think you're going to get 300 bushel on this. Well, Todd tells people he'd like to get 300 bushel. We'd all like to get 300 bushel. But this is really, really sandy soil, and Todd is really just trying to make money. His philosophy had always been, if he could do 75 bushels a year better over non-irrigated, that he'd make money and they'd pay for the system. So 75 bushels. Well, if you look down that row, he's 75 bushels to the good every year. And I know David Jocks, who did a financial outlook on this, said that, and I'm part of the paper too, said that you would need a 34% yield increase year in, year out to pay for the system. And David said it wasn't feasible. And I agreed with him on the 34%, that you would have to get a 34% yield increase year in, year out to pay for the system. So I agreed to have my name on the paper. What I don't agree with is that you can't do it, because Judge Farms are averaging over 40% over the years that they've had it. So anyway, that's what the corn looks like. Okay, we have some other growers that are south of Tillsonburg, Ann and Jeff Vermeersch, or Till Valley Farms. They bought this farm a little while ago. It was a former tobacco farm, very, very dry farm. There's about 80, I think it's 81 acres altogether. Ann runs her Pioneer seed operation out of that. So they, after 2012, when they had 90.4 bushels, it didn't really look good when you're selling seed corn right there, and you've got such crappy looking corn, so they decided they wanted to put subsurface drip in. So they did. So that was 2012's corn yield map. In 2015, the first year that they have the subsurface drip in, they went 205 bushel per acre. And there, I think it's pretty obvious. You can. 2016, we had an early drought, and you can see right here the drip tape at that corn looks way better than what we got in the front. We're growing pineapples in the front, but we've got decent corn out at the back. And 2016, they went 208 bushels per acre on that farm. They're not just looking at this, they're also looking, they have center pivots as well. I believe they have 2 center pivots, but Jeff is very positive about the subsurface drip. Now this is Jeff Lipsick. He's the other cooperator that we had. In the year 2015, his whole crop was frozen off on May the 23rd, but he still managed to get 187 bushel. And he has some test plots out in the field, and the best test plot went 207. 2016, again, they all had drought. He went 210 bushel, and he had a Pioneer variety there that he was really happy with. It was about a third of the field, and it went 242 bushel the acre. I should mention too, Jeff now has, I think he's our largest subsurface strip. He has 100 acres of his lightest ground under subsurface strip now. We had soybeans last year in our area at work at the Simcoe Research Station, and we had hugely visible difference between irrigated and non-irrigated. Now, a lot of people had told us that they didn't think subsurface drip irrigation would work on corn, but you could see the difference, and you could certainly measure the difference too. We were 28 bushels to the good on the subsurface drip irrigated corn. I thought you might be interested in the areas where these are the substantial subsurface drip irrigated farms that are in the province. As you can see, the majority of them definitely are in sandy areas, especially like around in here. This is all, I mean, the old tobacco sand is right in through here. We have one new one, and it's Snyder Farms at Snyder Sweet Corn at York. That they put in a corner of the farm this year that was hard for them to irrigate because they irrigate out of the Grand River, and they grow sweet corn exclusively on I think it's 105 acres at home. But they were so happy with the drip irrigation stuff that they put in that they're going to go ahead and do the rest of the farm this fall. So they've been very happy with it. So that just gives you an idea there. You want to know about this year? Well, I just pulled this out of Judge Farms there 2 weeks ago, and it's 20 rows around, and I'm counting 42, 43 kernels up the cob, and there was a lot of corn like this up there, so I think he's going to have a decent, pretty good crop this year. And it looks good right now. Every year we all learn something, right? And Todd's good at learning things. So anyway, that's just a sample there. Questions? I kind of blew through that in a hurry, didn't I, Bruce? As I'm
Can you
used to do.
I'll ask the first question. Can you talk about the fertigation aspect, or is that this afternoon?
No, we're actually doing moisture sensors this afternoon. I kind of glossed over that a little bit. With Netafim, that was the focus of our work. And do we have stuff to learn on fertigation? Yes, we do. We went kind of 2 different systems with the guys this year. Judge Farms at La Salette put on a fair bit of their nitrogen, as I did on our small plots at the station. We probably put half of our nitrogen on up front. So, and Todd probably put half of his nitrogen on up front. But as of the middle of June, we were taking tissue samples and fertigating to the tissue samples from that point on. Our initial tissue samples that we got in June were like borderline that we were okay on nitrogen and okay on most of our stuff. And Judge Farms have a high fertility level anyway. But Jeff Lipsick didn't put quite as much on to start with, and we noticed that he maybe wasn't going to fill the crop out quite as well, like quite soon in June. And so Jeff started feeding nitrogen weekly and in some case bi-weekly to the crop, and he was staying ahead of the tissue samples just until he had that big rain. And then he had to quit basically quit irrigating for a week, and he really felt that he fell behind on his nitrogen application. Now, this is a very good system in that you don't have to put all your nitrogen down. You can just go out there and put nitrogen on whenever you want to put it on. Like if you're behind at any point in the season, and it's not just on nitrogen. We had Todd started noticing he was having some sulfur and boron problems in about the second week in July, and he went out and put an application on there, and the tissue samples came right back up. And it's very quick and easy to do. You just have to have an injector to put it in the system. Very easy to calibrate, and once you have your flow meters and everything in place, it's quite easy to do. And boy, is it ever easy to do. You just hook it up and flip a switch, and no more moving pipe or moving tractors and guns and all that stuff that you have to do if you don't have the system. You do all the work the first year putting the system in, but we really think fertigation can really, and we're just scratching the surface on it too. This year was our first preliminary year on taking tissue samples all the time, and I know I've sure learned a lot from it, and I think we can improve on it next year. But the baseline is, to a certain extent, which Fred Bilo will tell you, you want to have nitrogen there in June to get the corn growing. And so we're learning from that. Yep. Yes?
So I'm just pondering, one of the things that you said was that you needed 34% yield increase to help pay for the system.
Yes.
And I'm not speaking to any of the farms that are in your study, but is this not promoting continuous corn? If you need to get that return in order to pay for the system, then what motivation would they have to plant a crop that has a lower value or a lower return? Because some of our problems are crop rotations
Sure.
or lack thereof in Southern Ontario.
Yes. Now this is preliminary stuff, and it has been on corn. Now, it hasn't been all corn. I didn't want to give that impression. They have grown soybeans on that land too. I have not seen any cereals on it, I assume, but they are looking at, they're putting in grass mixtures and that type of stuff. They're looking at that to try to increase organic matter. Now, I don't know whether that farm will ever go cereals. You're saying it should, and hey, who am I to say? But soybeans are on there too. There's soybeans on there this year, and there has been soybeans on there before. So some would say maybe we're trying to promote continuous corn, which is not a good thing, but that's not the basis of it. And at our 40-inch or 44-inch spacing, if we had a drought in the springtime, they tell us that we could still grow an even winter wheat crop if we had to. So I'm not promoting continuous corn. No, I don't want to say that, but that's a good point.
No, I don't think you're promoting it.
It might happen. Yeah, you're right. It might happen. But if we can get 28 bushel yield increase on soybeans, I think that kind of makes it worthwhile too.
Any more questions, Richard?
So what you showed is mainly flatter ground. What about the add hills? I don't see it working on hills.
That's a good point. That's where this tape that I've showed you is a non-pressure compensating tape. So you are limited in the length of your runs, like probably 1,100 feet on fairly flat ground. Now, those of you who ever get the chance to go by York to look at Tom and Brenda's place there at Snyder's Sweet Corn, they are on hilly ground, and they have gone to a pressure compensated. I have one of those up here too. Now, it's more money, but they're convinced that the system will work, and they're doing long runs. They're sticking with their pressure compensated. It's not a lot more money. I think it's about 25% more and they can go on quite hilly terrain with the pressure compensated system. I've seen some reasonably hilly farms in Kansas that were doing that as well. So it's more money for sure. The easiest way is non-pressure compensated flat ground, but yeah, there are ways around it if you see the need for the water.
Pardon? Judges has a good role. There's got to be 25 feet, 30 feet between the pond and the chicken run.
Yeah, that's not that bad. That's not bad. When we're talking Snyder's, we're talking, no, that's for sure. Yes? Kansas, we're telling people 15 years, okay? You're going to have maintenance. That's one thing I should, when it comes to system maintenance, you want to flush periodically, as I mentioned, to get the dirt out, get that sort of thing, or accumulation of deposits in there. And we acid treat it at the end of the season to clean out anything that might be laying in the tape and flush that out. It doesn't take long and it doesn't use up much water. So we're telling people 15 years. Kansas State has, they have an economics program that they compare center pivots to subsurface drip, and they have to keep changing the economics of that every year because they have one system that's now been in the ground for 26 years and it's still within 10% of its output. So it's all about, it's like all farm equipment, care and maintenance makes a difference. So